Welcome back everyone to my math channel online today again. In this video today, I would like to share with you my knowledge about the polynomial function in the course of pre-calculus math 12. I think that it's important to share with you this video I created today to demonstrate about the characteristic of the polynomial function, as well as some of the important terminology involving about the function in the mathematical language. And I think it's important to let my student know about the general ideas, about the concept, what the function looks like before we actually learn about the function, about solving the equation of the function and apply the function to solve the various problems in real life problems. So let me share with you the topic today, the lesson today about the general ideas of the polynomial function. However, in my video today, I would like to show you in the way that I share with you the screen and the whiteboard rather than like I'm standing at the whiteboard and using the markers like I always do. Why do I think about this? Because depend on the topics, right? I feel very comfortable if I have to sketch the function by hand using the whiteboard and markers, not using the mouse. And some teachers are good at technology in advance, they might be able to use that. Unfortunately, I am not a high-tech person, but I try my best to give you a various way of how to deliver the lesson and how to present the lesson to you in more attractive way and more engaging and variety. And everything is a learning curve, right? So I hope that each day I will deliver to my audience better and better on the videos each day. But I also ask you to give me a little bit patient and forgive me if I'm so slow in technology. And so just please bear with me and be patient with me. So I'm going to share with you the lesson today on my computer lab. I will demonstrate it on the whiteboard here. And forgive me if I make any technical mistakes or stop or disrupt or whatever, but I will try my best. So let's see, I know that I'm not going to be able to record one time and play it and deliver to on YouTube, but maybe I have to record like 5 times or 3 times, but let's see, I'm going to try my best. So I'm going to share screen with you here. And so I'm going to say share. Okay, so now I would like to also share with you about the whiteboard. But let me, okay, it's right here. So we have the whiteboard and we also have my little face on the screen on the top corner. That's good. So let me talk about the polynomial function. So first of all, let's see what the polynomial function looks like. So a polynomial function is a continuous function. Is a continuous function, which is which has no gap, no break, or no home. And I think that you already know this, what I mean, but I'm going to demonstrate to you. So for example, if I draw an ugly polynomial function here, and obviously this is the continuous function, because when you start the pen, right, and you continue to draw it without, you have to pick up the pen up and bring it down. So in the case, if it had a home, it will look like this. There's a home on the function, right? So at this home, the function does not exist. Or sometimes you might have a function look like something like this, and then there's a gap here, and then like that. So in this case, you can see this is the gap, right, in between the functions. So here is a break as well, right? The function is not continuous. So obviously, this is the two case function. These two functions are not the polynomial function. So that is the first condition to satisfy the condition for to be a polynomial function. It have to be continuous. So the third one here, as I demonstrated, and doesn't matter how many times it turning point, whatever. This one is a continuous function, and this is the polynomial function. So this is not, I'm going to cross it out, or I'm going to erase it, right? We don't want this, but we want this. This is the polynomial function. So that's the first condition. Now, let's see what is the next condition. So the next condition for polynomial function, we'll talk about a polynomial function can have an odd degree or even degree. And when we're talking about degrees, we're talking about the highest degree in the function, right? For example, if I have a polynomial function here, let's say x to power 4, and a hat here, a little hat here stands for the power, right? Because I cannot tie in the power in here. Let's say if I demonstrate it by the, no, because I use it, so I cannot use it anymore. I have to use it typing. So x to the power 4 minus 3x to power 6 plus x and minus 23. So for example, this is the polynomial function. Now, the highest degree of this function is 6. So we care about the x to the power 6. We don't care about x to the power 4. So that's what we mean the degree in the function, right? So this is an even degree because we have power 4, we have power 6, we also have power 1. However, we care about the power 6. So when we're talking about the degree, usually we talk about the highest degree of the polynomial function. Now, what is the odd function? Of course, for example, the odd function like x to 4x to power 3 minus 5. So even though we don't have another x here, right? Obviously, this is still a polynomial function. Okay, so now we get into, we get done this idea. So I am going to go down and see if I can move down. Let me return to the text so that I don't have to open another text. See if I can move down on the screen. Right, I'm stuck here. That's why I told you I'm so sorry. if my technical problem occur. Now, obviously, if I tie in the next one, it's gonna keep moving down for me, I hope. Okay, so what is the next point I want to talk about? The polynomial function. So we talk about the odd degree and even degree. So now I'm going to talking about the so let me see. So let's see the second one. I'm going to talk about, my second point is how to identify a polynomial function. So I'm going to key in a bunch of functions for you to check for me, are they the polynomial function or not. So let me clear on the drawing. Okay, so let me get back here. So let's say if I have a function number 1, look like this, minus 2x to power 3, x power 3, and plus x squared minus 5. So that's the first one, right? Now I'm going to do the second one. I'm going to do second one. So let's say the second one here, I have the square root. I have to find the square root here. Ooh, that's my problem. See, let's say minus 1/3 x square plus square root. I could not do square root. So what I'm going to do is I'm going to write here. So I'm going to erase this number 2 here. And let me erase this. I am going to draw it instead. I'm going to draw in here. So let's say I have a number 2 here. And forgive me, this is very ugly, right? So let's say I have the square root of the 2 and then x to the power 4 and minus square root of 3x and plus 2. So that's the second question, right? Okay, so now let's say I'm going to have the third question, like minus 1/3 of x to the power 2 adding with square root of, I'm getting so ugly now, square root of minus 2 and x outside the square root and plus 1. Okay, so now let me get back to the next one. Text again to make it better. Let's say I have a 3x plus 2. Say I have a polynomial, right? Let's make a little bit fancy. 3x plus 2. Oh, because I don't know whether or not it is. We have to identify it first, right? So let's just key in the algebra. This is 3x plus 2. Now I'm going to make another one somewhere here. Let's say it's just 7. Okay, so now let's say yes or no with me, right? So let's say I have a bunch of polynomial function like this. Minus 2 to the power 3 plus x squared minus 5. Now, you will tell me yes or no in the first question. I guess this is the polynomial function. There's nothing wrong. So I'm going to say yes. This is the polynomial function. Now let's look at the second one. Is this a polynomial function or not? If we given the algebra look like this, square root 2 of x outside, the x, make sure you make observation, right? The x here is outside the square root bracket, right? There's only number 2 inside here. X to the power 4 minus square root of 3x. This time the 3x here inside the square root, both of them, and plus 2. Now, yes or no? So I'm going to give you 1 minute to 1 second to think about it. Now, my answer for this question, I will say no. This is not the polynomial function. But how do we know this is not a polynomial function, right? How do we know? If we're not using the graphing calculator, if we're not drawing it on the sketching it or whatever, how do we know? Okay, so my hint to you is if the number in front of the x to power 4 here inside the square root and it had no problem. So then I would check, right? I would check the first one be okay, right? That pass, that's a polynomial function. However, if you look at the middle term here, right? We have a square root of 3 of x. Once you have a variable inside the square root like this, right? This look like a radical function rather than the polynomial function. So you can see that's the difference, right? This x to the power 4 outside the radical function. That is okay. But this x is inside the radical function, and this is not the polynomial function. This should be a radical function. And therefore, because of the mismatch like this is not a polynomial function. So we say no. Now let's look at the number 3 here. And I apologize for my handwriting, right? But I hope that you still can recognize it. This is minus 1/3 x squared plus square root of minus 2 x outside plus 1. Unfortunately, because of, so the first condition is okay as well. This one look okay, right? Now this one not okay because we never can have a square root of a negative number. So right at the beginning, this is the violation already, right? Not even consider anything else. So our answer for this will be no again. No, this is not the polynomial function. Now let's take a look at the 4 one, and I should key in this is the 4 algebraic expression or 4 equation, right? Is this a polynomial function? Yes or no? Now, I'm going to give you 1 second to think about it. It looked like a linear function, isn't it? It looked like a linear function, but it doesn't violate any condition of the polynomial function. We say that the polynomial function can have an odd degree, which is right here. The linear function here has an odd degree of power 1. No gaps, no holes, no breaks, and it is straight line. So yes, so it is one of the polynomial function as well. Even though we call it linear, but we classify it as a polynomial function. So we say yes. Now let's take a look at the last one, number 5 here. Is this a polynomial function? That's only one number. That's not even the function, right? So when we have a function, we should be able to identify the degree of it, right? What else do we identify? So if this is the function, I just say 7 equal y, right? So yes, this is a function, right? If you draw it, okay? Then let's say right here is 7. Then your line will go through your line will go through this drawing, right? This is the function go to number 7, right? Let's say go to number 7, okay? So yes, this looks like a linear function as well, right? But how do you know is this a polynomial function or not? Now, in order to know this is a polynomial function, I'm going to write it in a different way, okay? So instead of writing like this, I'm going to write this one as, give me, I'm going to say this is a function y equal 7x to power 0. Is that okay? It's perfect sense, right? Because x to power 0 equal 1. 1 time with 7. Now, when two algebra stand side by side together, without the plus sign or negative sign between them, they are multiplied together. So this number 7 multiplied with x to power 0. So here you go, you have a polynomial function with the degree of 0, and no gaps, no hole, no breaks. So my answer for this, I'm going to say, yes, this is a polynomial function. So that's how I show you how we identify what is a polynomial function given a bunch of algebra expression. And we don't even know how it looks like. We're not drawing it. We're not sketching it. We're not keying the graphing calculator and find out. So that's the way you identify the polynomial function. So this is my second point in this lesson today. First, I'm going to show you the polynomial function is a continuous function. No gaps, no holes, no breaks. Second, I'm going to give you a bunch of algebra here, right? And you help me to identify, are they the polynomial function or not? Which one is yes and which one is no? So that's my second point. In this lesson today, I try to demonstrate it to you. Let's go on for the next one, right? The next one I will talk about, okay, so let me key in the next point. Let me clear it, the on drawing. So I'm going to tie in again, okay? I'm going to say for a polynomial function of even degree, let's say like that, right? Even degree. And that means x to the power 4, x to the power square, x to the power 6, blah, blah, right? It has at most, we have at most and real 0, and at least, and I don't know why my typing is so narrow. I'm going to move this. Okay. And 0 and at least, and I should separate the word, right? At least non-zeros. So we will have at most and real 0 and at least non-zeros, and at most and minus 1 turn point. Okay, now this sounds complicated, right? So that's why I want to show you and demonstrate the concept. So for a polynomial function of even degree, it has at most n real 0. So let me demonstrate that's what 0 means, okay? Now bear with me if I draw a very ugly graph because I don't know how to produce a nice graph. Okay, so let me try. So let's see if I have, oh, that's not bad actually. If I have an x and y axis, right? And I'm going to draw the polynomial function. So let's say if I draw the polynomial function look like? And it should be even degree, right? Okay. So this is an ugly function I draw, but this is a polynomial function because no gaps, no hole, no breaks, right? Now, what degree of this function? The degree of this function based on its roots, right? And its roots, right? Its roots. Its roots. I'm going to type in. Okay. Its roots equivalent to 0. We count this, right? And why do we count roots is 0? Now, the root of function based on the x-intercept, right? Whenever the function hit the x-axis here, so this is the x-axis, right? This is the x-axis, this x. So this is y, obviously, right? This is y. Now, if the function hit the x-axis right here, at one point right here, second point right here, third point right here, right? And fourth point right here. So this we call a root of the function. But because this root is the y function, right? And the y here equals 0. Any y here, coordinate here equals 0, right? The x could be this, it could be -3 or -4, but the y here is 0. And the x here could be 0.5, right? But the y is 0. And the x here could be 6, positive 6, but the y is 0. So all of this based on the y equals 0s. And that's why they call the 0 the same like the roots of the function. So 0, it should mean x-intercept of the function. Or another way of we call the roots of the function are zeros. Now they try in mathematics, they try to put in the terminology term zeros. But now you know because it crossed the 0 of y, the y coordinate 0, right? On the x-axis, so they call it 0. So now let consider the sentence again. Let read the statement again. For a polynomial function of even degree, it has at most n real zeros and at least non-zeros, and at most n-1 turning points. So now I explained to you the 0, and here we know this is the degree 4. So we have a function here with x to the power 4. Now anything else we don't know, right? We don't know, maybe it plus the 12x to power 3 or whatever it is, right? We don't know. We should understand this is going on, right? But we're not going to know what exactly the algebra for this equation for this function, right? So something like this. But we know the higher degree is x to the power 4. What else do we pay attention? The direction of the even polynomial function. And you can see that they both the same direction. So they start from down here at negative, right? Portion of the y-axis. And they're going on, and then they end up with the negative as well. So for the even degree, you can pay attention to their direction as well. This we call end behaviors of the function. So the end behavior function, if it has the same direction, if they both going down like this, right? The same, then the chances they are the even degree function. If they in opposite direction, and what do I mean in opposite direction? I mean opposite direction like, maybe I have to demonstrate the one. I don't like it, so just give me a second. I would have to use the maybe different color, try to, give me. So I'm gonna say, okay, let's say here you have another function and it looked like something like this. Let's say you start down here as well, but then it's going up here. right? Now you can see that the end behavior direction of this polynomial function, right, is it not the same, right? You can see that this is down and then go up. So the end behavior of this function is not the same direction. And this you also can say this is the odd function. It's not the even degree because the direction are not the same. So that's one of characteristic I want to show you, right? Point out to you. Now, what is the, it say, and at most n minus 1 turning points. So for a polynomial function of even degree, it has at most n zeros and at least non-zero. Now, why they have to use the word at most or at least? Because you might have the polynomial function crossing the x-axis like this, but you also have a situation something like this. Let's say a quadratic function, something like that. And you see that if this is the case, right, let not just say the quadratic function, but let's say you have a function look like that. Now, obviously, this function never crossed the x-axis, right? You don't know how many degree in here because you cannot count how many zero it look like, right? You cannot count like that because it start from up top here and it never touched the x-axis. But this is still a function and they have the same direction, right? They both go up at the end points here, the characteristic. So this look like a polynomial function, no gaps, no holes, no breaks, and it doesn't have a roots. It doesn't have a 0 degree. In this case, sorry, it doesn't have a roots and you cannot count the zeros, right? So in this case, you only can inspect by looking at the direction of this function. They both the same going up and not like one up, one down like this one here, right? This one here is odd function for sure because it's one up and one down, right? So this is odd and this is even. But this polynomial function here doesn't have the roots, doesn't cross the x-axis, doesn't have an x-intercept. So we cannot count how many degree of this one have, right? We don't know yet. Now, so therefore, the word at most, it has at most n real zeros and at least non-zeros. So you see that at most n real zero, what does that mean? If this function is the degree of 4, x to the power 4, then at most the zero of it is x1 here, x2 here, x3 here, and x4 here. It cannot, if you have a degree of x to the power 4, it cannot give you 5 roots or 6 roots or 7 roots. It cannot exceed the highest degree here. So if polynomial here is x to the power 4, the maximum roots for this polynomial function is 4. It cannot be 6. It cannot be 8. And that's why they call it at most n real 0, n real. And depend on how many degree of this one here. So this is 4 degree, it have 4 real 0 here. At least non-zero, this is the case when I draw it here, at least non-zero, right? Obviously, this is still a polynomial function, but it doesn't have any roots. It doesn't have any zeros. It does not crossing the x-axis. That's what it means. And therefore, they say at most non-real 0. The maximum you only can have is if the function have a degree of 4, it only have 4 roots. It only up to 4 roots. Now, sometimes you might have a function x to the power 4 or x to the power 6, but it might have 3 roots, or it might have 2 roots. depend on the shape of the function, right? Even though the even degree function, but you might have a root less than the number of the degree n degree here. So let's say if x to the power 6, let's say this function is x to the power 6, but you only have 4 root here, right? For something like that, and therefore you say it has at most n real zeros and at least non-zero. So this is the k at least non-zero. Now another k, it could be something, let's say a parabola down this way. Now you can see that this also a polynomial function we call a quadratic function. We learned already in math 10, right? So this parabola doesn't touch the x-axis down here, and it keeps going down like this, the arrow direction, right? Showing both in the same direction going downwards, and it have no zeros. And that's why it say at least non-zeros. Now let's talk about at most n minus 1 turning points. This I have to show you a little bit. N minus 1. Now, what n minus 1 mean? Let's say if this polynomial function is x to the power 4. N minus 1, it means 3, because 4 minus 1 is 3. So maybe this polynomial function is x to the power 4, but only have 3 turning points instead of 4 turning points. And that's why they say at most it up to, right, at most n minus 1 turning points. Okay, so let's explain what is a turning point to you first. Okay, so let me clear the let me erase this on this. Oh, I had this, so I'm gonna have to clear everything first. Okay, so turning point. So let's find out what is the turning point. What is a turning point? So let's say if I have a function, let me draw on the coordinate, maybe better this way. Okay, let's say I have a function. Okay, and I'm gonna function turning point. I try to make it pretty as much as I can, but maybe not. Oh, so. Okay, so this is the polynomial function. How do we identify the turning points? Now, if you have a function like this, we call a concave up, right? And if you have a function like this, you call a concave down. So let me tie in this. So this is concave up, and this form we call a concave down. Maybe I should have stand at the board and demonstrate to you it better. So you see concave down. Okay. Now, if you have something like this, let me demonstrate it here. Let's say you have a function going concave down like this, right? But then it changed. I'm not so good at it. Okay, let me try again one more time. Let's say if you have a function going up like that. And then uncertain going down and going up again. Again, I don't like it, right? And that's why I said to you that I'm so sorry. I cannot do even the better. So let me try one more time. Just be patient with me. One more time. Okay, let's say I have a function concave down and uncertain concave up like that. Wait, what is the turning point? Now, all the way from here to up to here is concave down, right? Concave down. And now, start from here, you can see it look like, no, sorry, all the way from here to here is concave up, right? And then start from this point, you can see that it go down, it look like concave down, right? So the between here, when the behavior of the function changing from between concave up to a concave down, we call this is a turning point. So this point right here is a turning point. So the turning point is the point where the function changing from concave up to concave down, or from concave down to concave up. For example, which point in here? This is the function going down, right? Going down all the way from here to here, concave down, right? Concave down. Everything from here to here, concave down. Now, where is turning to become concave up? Right about this point, right here, right? It's changing between the concave down to the, from concave up, change to concave down, right? So this is the turning point. So when they say that the polynomial function has at most n-1 turning points, it means if you have a polynomial function with the degree 4, it could have up to 3 turning points. It never have 4 turning points, right? Because we say n-1. So therefore, if a polynomial even degree function is, let's say, degree 6, it could have up most to the turning point of 5. But also it could have 1 or could have 2. Maybe 1 is not a case, but maybe 2 or 3 can be a case as well for an even function to have how many turning points, right? So pay attention to the turning point. It's just the point where the function change from a concave down to concave up, or from concave up to concave down. So that is we call we call it turning points. Okay. So now let me erase all of this. Let me clear all of this again. Now you know what turning point means. So now let me tell you another characteristic of polynomial function. So that is about the even. So what about the odd? Okay, so now we talk about the odd. For an odd polynomial function, it will have at most n real 0. So this is the same, right? At most n real 0. So if you have a function with degree of 3, then it have 3 0 is at most. Maximum it has 3 0. Okay. And you know what 0 mean now, at intercept, right? The roots of the function. So it can have at most n real 0. What else do it say? It have at least 1 0. Okay, so here is the difference with the even function, right? The even function say it only can it have at most n real 0 which is the same. However, at least non-zeros, non-zero, no zero at all, not crossing the x-intercept at all. But for the odd function, at least it have to have 1 0. And why is it like that? Let's analyze by looking at the graph. Okay, so I'm going to show you the graph again. Let's say if I have an x-axis and a y-axis like this. And I have an odd polynomial function. Say my polynomial function is a symbol, the lowest degree, right? Let's say, of course, not a linear. So I'm going to draw something like this. So this curve looks like a inverse of x to the power 3, not inverse, but like a reflection of the y equal x to the power 3. So this looks like minus, right? Minus x to the power 3. Now, this is the reflection of x to the power 3 over the y-axis, right? Because we have a negative in front of the x here. Okay, so it has at most n0 and at least 1 0. Now, obviously, you see that it has to across the x-axis at one point, right? Now, let's say if we have another function. Okay, let me draw another function. And I don't know if I can choose the color. It's different color. Okay, so I'm going to choose the red color here. Let me draw another function. Let's say I have another function, something like this and like this. And you can see that the direction, because the direction of the odd function, right? One up, one down like that, right? Let's say you start here. Or even though you start from down here, and then it go here, and it go back here, right? So one down like this direction, one up like this. So because one of them is down, one of them is up, it have to across the x-axis at some point. Even though you start the function from here, let's say you start function from here, right? And you think that, oh, this is not going to be able to cross the x-axis, but actually look at the direction. Because it has to be one up, one down. So that's the case. If this function have to somehow, if you wrap it down, it have to across the x-axis as one point. And therefore it say at least 1 0. It have to across the x-axis at one point. It doesn't matter how many degrees it is, right? Could be x to the power 3, could be x to the power 7, could be x to the power 5, but it eventually, because the direction of the end behavior allows for the function have to across the x-axis at least one point. And therefore, we know that at least 1 0. So that is the statement about. So that is the top point we're talking about, right? Okay, now what is the next thing I would like to say? A polynomial function is written in standard form if its terms are written in descending order of exponents from left to right. So usually when you write the polynomial function, right, you always write in the descending order of higher degree first. Let's say you would say polynomial function equal, let's say odd function, x to the power 7 minus 1 over 4, right, minus 1 over 4 x to the power 5 minus 12x square plus 45. Let's say this is a polynomial function, right? So you see this function always written in the highest degree first, and therefore we call it descending order. So it has to be 7 and then 5 and then x to the power 1 or x to the power 2 and then no x here, right? It cannot go in the mix up like usually that's the way we write the polynomial function. We put the highest degree first. Doesn't matter negative or positive, we put the highest degree first. And then if you have x to the power 6, then the x to the power 6 will go next to the x to the power 7 instead of x to the power 5. The reason here because we don't have an x to the power 6 here, right? So if we have an x to the power 6, you should put right next to the x to the power 7 first. So that's what it says about polynomial function. So now, when it say, another thing I want to mention in this video, when it say that x equal a is a factor. When it say x equal a is a, no, sorry, is a root, right, of the polynomial function. Polynomial function. Then x minus a, then x minus a is a factor. Okay, so you know that any polynomial function, for example, the quadratic you learned in the past, right, can be factorable or can be unfactorable. But let's say if they are factorable, then each of them, like the bracket here, if x plus a is the root of the polynomial function, then x minus a is a factor. Now, if you have x plus a is not a root of polynomial function, right? Then that is not a factor. The factor only occurred when these brackets multiply together, produce a 0 right here for you from the polynomial function, right? So let's say if you have, let's say you have a quadratic function, okay? So let me key it. Let's say you have a quadratic function, y equal x plus 3 times x minus 2 times x plus 1. So this is obviously is a polynomial function. Have a degree of 3 because you have x1 times x1 here is x2, x2 times x1 here x3. So this is a cubic function. Now, all of these are the 0 function because you know that if you multiply all of this and it gives you a 0 on the right hand side, then x, you can set each bracket equal 0 and so on for x. So minus 3 is the root of the polynomial function, first root, plus 2 is the second root, and minus 1 is the third root of the polynomial function. So basically, in this video today, I have shown you on the characteristic of the polynomial function. So let me give you a last one, okay, a last touching concept in here. Let's say if I have a bunch of polynomial function, okay, I'm going to draw it. And now we're going to identify which one is a polynomial function, which one is not, okay, by drawing. So let me draw another one. So I draw. Okay, so let's see. If I have a function, something look like this. Is that a polynomial function? Yes, right? Even though it is look like a linear, a straight line, but the answer is yes. Now let's say if I have another one like this, then of course the answer will say yes as well, right? This is the polynomial function. Now let's say if I draw something weird, let's say like this. Okay, yes or no? What do you think? Now, my answer to you in this case, right? I'm going to change a different color, right? You can see from this point, right? My function look like this. Everything here like a concave down, but here is, this is a sharp point, right? A sharp turning point. It's not concave down or not concave up, whatever. It just go down here is a concave down, but then sharp, turn sharp like this, right? So this, you call a function with the sharp point like that. I believe you call it gaps. No, not gaps, but it like curves. Let me tie in otherwise. Okay, so this I call a curve, right? A curve right here, a curve, because the function going smooth like this, right? On a sudden like this. So this is the sharp turning point, and this is the sharp turning point here is a curve, and therefore this is not a polynomial function. So my answer to you for this question will be no. This is not a polynomial function. What else I can demonstrate? For example, another one, let's say I have a function look like on the way like that, right? And then suddenly it break and then continue going up, up, up like that. So you see, this is the whole thing like break, right? So in this case, you also say, no, this is not the continuous function, therefore it's not a polynomial function. So I guess this is the end of the lesson today. For all of you, remember what is a polynomial function. And I am apologizing for the way I use the mouse very bad because lacking of practice. I usually just want to use the ball, and that's why I'm standing on the ball and demonstrate it on the ball on the time for you. Maybe that's one of my weakness, and I try to overcome now, try to give you the variety of way of saying it, right? How to, sorry, I have to get rid of this word. No, and make even worse. So let me, how do I maximize this one? No, I'm done. Give me a second. And whiteboard, close the whiteboard. Okay. Now you see my ugly face again. Okay, so that's what the lesson today I would like to demonstrate it to you, right? I would like to show you that yes, there's a various way of identifying what is a polynomial function using the algebraic expression. Try to identify which one is a polynomial function and which one is not, and what the x-intercept and zeros mean in the polynomial function, and what is the turning point is the important thing, right? You should know how to identify the turning point of the function. And because that will relate it to the next lesson when we have to factor the polynomial function out and identify the turning points for the next lesson. And that's why I make this lesson today to give you the general idea of what the polynomial function means to you, and we will have a lot of fun in the next interesting video lesson. We will solve the polynomial function, and I think that I already showed you how to divide the polynomial function using long division. We haven't learned about the synthetic division, but we also learn about the remainder theorem. My next video, stay tuned for that. It will be about the synthetic division of the polynomial function plus with the factor theorem. So last week we learned about the remainder theorem from the polynomial function. Now this week, I review a little bit about the characteristic of polynomial function to you, and I mentioned I will show you the next lesson, which is synthetic division of polynomial function and its factor theorem. So thank you for watching and patient with me for the new technology I'm using today. It's not showing very rich on the board, but at least I can break it down the concept and explain to you what the turning points mean, what the zeros mean, how we use it in relating to the polynomial function. So that's my purpose for the video today. Thank you for watching, and bye for now.